Hi, everyone, and welcome to Foundry Virtual Events. My name is Joyce, your marketing host for today. Today's session is recorded and will be available after the webinar finishes. We're also doing a Q&A towards the end of the webinar, so make sure you stay with us towards the end. I'm here today with our three lovely panelists, Hendrik, Proosa, founder and CEO at Kaldera. We've got Mads, Hagbarth, Damsbo, VFX TD, compositor and supervisor and owner of Higx. We've got Sam Hodge, founder of Kognat. And then we also have Ben Kent, research engineer manager at Foundry, who will be hosting today's webinar with me today. So thank you guys for joining me today. Thank you, Ben, for joining me so early as well here in London. And looking forward to doing this webinar with you guys. So we've got over 80 on-demand webinars available. So for more information, you can go onto our dedicated Foundry events page or our dedicated Livestorm page as well. We've got two more webinars coming up. We've got Foundry Innovation Machine Learning happening on June 15th, and we've got a Modo webinar happening on June 23rd as well. For any questions, any feedback, or you want to participate in our virtual events, you can send us an email on virtual.events@foundry.com. We have a dedicated page for our learning materials where we host a lot of our tutorials as well at all levels for all of our softwares. We've also recently just launched Victor Perez's color management training material. We've got part 1 available for free, which you can watch on our Foundry Learn page. We also have a page called Insights Hub, where we host a lot of really, really cool articles, industry trends articles, artist spotlights. So for more information on that, you can go into our Insights Hub. For any activities, events that we do, you can follow us on social media as well. I just also want to do a massive shout out, a massive thank you to all the studios, speakers and artists who have so far participated in Foundry Virtual Events. Thank you so much for sharing your stories, for showcasing your projects. And we're really looking forward to bringing many more stories to you guys as well and working with many more studios. So thank you again. So enough about Foundry. Let's dive into CopyCat. So Ben, can I hand over to you to talk a little bit more about CopyCat and what are we going to be doing in today's webinar?
Sure, thanks Joyce. I'm Ben Kent. I'm the research engineering manager at Foundry and also the lead on the AI research team. So welcome everyone to CopyCat in the wild. So I'm sure everyone in the audience already knows what CopyCat is, but just in case there's anyone who hasn't seen it or had a chance to play with it, I'm going to quickly do my standard spiel for it. So CopyCat's a Nuke X plugin. We recently released it in Nuke 13 as part of the first set of the AI research tools. And what it does is it allows a user to train a neural network to create their own custom effect specific to the shot or the set of shots they're working on. So you feed it a small set of before and after images with and without your effect, and CopyCat trains the network to replicate the transformation from one to the other. So, for example, if you wanted to do some garbage matting, you could mask just a few frames, pipe those frames and the associated masks into CopyCat, hit train, and it would learn how to reproduce those masks on the rest of the sequence. So when we were developing it, we tried it on matting, beauty work, deep blurring, but in theory, it should be able to work on any image-to-image effect. So we always say we're putting machine learning into the hands of the artist's imagination, which leads me nicely onto our amazing panel of artists / Nuke and AI gurus who are here to show you all examples of how they've been using CopyCat out in the wild in super cool imaginative ways that I'm sure we hadn't even considered when we were developing it. So at that point, let me hand over to the guys to introduce themselves. Hendrik, should we start with you?
Hi, everyone. I'm Hendrik from Estonia, and my background actually is in geography. And hello to Andres Kluge from Estonia, also a geographer in Peoples. I studied geoinformatics in university, and strange enough, my thesis was about like feature detection and kernels and remote sensing. And now, after 15 years, I have somehow gravitated back into the same topics in the machine learning area. because what machine learning is basically also a bunch of convolutions and kernels and detections and features and so on. So it's really interesting for me to be back in basically the same area, but from the different perspective. And at the moment, I'm working as a comper and supervisor in my own company called Kaldera.
Thanks, Hendrik. Mads, tell us about you.
Yeah, my name is Mads. I'm a visual effects technical director and pipeline technical director from Nordisk Film Shortcut. We've sort of dived a little bit into AI and machine learning sort of at work. And I think that just the introduction of CopyCat now sort of accelerated that because, it made it a lot easier and a lot more approachable for us, the users and the artists, so we don't need to get a ton of things, a ton of dependencies, and set up complex setups in order to get this stuff going. So yeah, it's I'm still sort of what do you say? It's like very basic knowledge, I guess, and it sort of accelerated over just the last year or something like that since I really started to get to know the tools. So interesting.
And last but not least, we have Sam.
Yeah, g'day. Sam Hodge from Adelaide, South Australia, and I've got a pretty long background in visual effects for feature film. Sort of worked for 15 years at Rising Sun Pictures and put in a little stint on Avatar at Weta Digital. And at the age of 42, I retrained into computer science, and towards, I don't know, about 2016, 2017, I started to get interested in style transfer and, would do crazy things like make my cat into a Hiroshima Bosch painting and all sorts of crazy things like that. And then when I finished my studies in computer science, I founded a company creating a tool for the visual effects industry, and that tool's called Rotobot. And, I've just got so interested in machine learning, I sort of do it for my day job now. So, yeah, that's enough about me.
Thanks, guys. Back to Joyce.
Perfect. So as Ben said very briefly, we've asked each of the panelists to put together a very short video just showing some of the examples and experiments that they've done in CopyCat. So let's go over that a little bit more in detail. We'll cover all the 3 videos now, and then we'll go ahead and dissect them a little bit more and then cover them in more detail. So first, let's start with, I'm going to put you, Sam, I'm going to put you on the spot there and start with your video. So this is the first example by Sam.
Okay, so I'm not going to spend a lot of time on this, but what you should be able to see here is some pieces of string pulling on a rod, and those holes where the pieces of string are represent data samples, and the rod is the best fit for how we can create something that fits through those samples, right? So if we had something like a bag of fruit, and the bag of fruit was 20 cents a piece of fruit plus 10 cents for the bag, we could come up with a cost function, right, which is 20 cents times the number of piece of fruit plus 10 cents, right? So what this says here. And what you can also have is you can have like a function, right? We could call this function f of x or y, it doesn't really matter. And then we could factorize it out so that it's 20 times x plus 10, where x is the number of pieces of fruit. So that's like a function of x. And then you could say that this is actually a generalized linear function where we've got m being the cost of the piece of fruit and c being the cost of the bag, being mx plus c, which is like a linear function, right? And then what you could do is you could actually try to turn this round the other way, that we'd have a number of data samples so that we say, well, we've got this bag of fruit cost 50 cents, this bag of fruit costs 70 cents, this bag of fruit costs 90 cents, and the number of pieces of fruit are 2, 3, and 4, right? So what we could do then is say that we've got the input, which is the number of pieces of fruit, and then we've got the output, which is the cost of the bag of fruit. And what we do is we put together a model which says it's the number of pieces of fruit plus the cost of the bag, and we'll actually want to find out how much the each piece of fruit costs, which is the value M, and how much the bag costs, which is 10, right, which is C. So this way of solving, we've got two things, and we can actually solve that analytically because we don't actually need to. But when you've got something bigger with more variables, like fitting a 3D plane to 6 points, you can actually learn the parameters, right? So you can sit there and say, what's the best fit, by approximating and then changing the angle of the plane until you get the best fit. And we do this with machine learning, and we do it, each attempt is called an epoch, and we get closer and closer until there's pretty close to the final thing. So what that means is that we, rather than just having 2 parameters or 6 parameters, we use millions of parameters, and then we can do crazy things like pull us a real-time mask off a piece of video. So what I've done is I've created a number of inputs, which will be the number as a piece of fruit or a fence with colors on it. And then I've got the desired output, which is a fully rendered fence, right? So I'll jump out of my slides and I'll come into how I produce them. So in Houdini, I've got a render of the input, right, which is like this, and then I've got a render of the lighting, which is the output like that. And I've taken that into Nuke, right? And in Nuke, I've got the image sequence here loaded up with all of the sort of ID colors or whatever. So the posts are yellow and the runners are pink, and then the vertical bits are sort of this lavender color. And then I've also got the exact same position. I've got the full lighting, and I've got a CopyCat node here, right? And so just in the same way we were trying to learn the angle of that piece of plane, the loss function goes down and down and down over more and more steps until we've got a closer representation of how to get from this to this by learning it with machine learning, right? So once we've got that, the really cool thing is I can produce a scanline render of this pretty easily, right? And that's pretty cheap. Or is it? Right? So that will render through, and this render looks the same as this render, right? So that means that if I put an inference node down, which has learned how to turn this into this, you can also learn how to turn this node, which is the scanline render, into this node, which is the final render. So then I can unpre-multiply that, shuffle it around, and get the final result, and then pre-multiply it so I don't get any nasty edge effects. Which means that if I wanted to, I could have, say, 30 shots that needed a picket fence, and just render out a cheap and nasty scanline render of this, and then by loading up the value of this .cat file into there, I could have them all lit beautifully by using the one-learn lighting, and wouldn't actually have to render this ray trace rendering, which I can just show you now takes a bit of effort. So that's just one application of CopyCat, and if I go back to this, I'll be able to show you that I can get from the input to the output just using a CopyCat node, and not having to spend time rendering every time that one of the things that updates the input, like the camera angle or the distance from camera or whatever, and that can just update on all shots. And so if I did want to change the lighting, I'd update this training run, and then I'd load up a new cat file into this CopyCat inference node, and then this would come out looking different with the new lighting. I haven't got an example of that, but it's just one way to show how CopyCat can work. Thanks for your time.
Thank you, Sam, for putting that together. Is there anything you wanted to share before we dive into the next one?
Yeah, I don't know if it was really clear that that was actually taking the geometry and just rendering out a facing ratio in the scanline renderer in Nuke. And so the ray trace renderer using Arnold in Houdini would be quite expensive, but inferring an approximation of that just saves on rendering time. But there's a cost of training it as well. I think that it should be fairly clear about what I've done there.
Definitely. Perfect, thanks. And we can dissect it in more detail a little bit later after we've covered all of them. And just for the audience as well, if you have any specific questions for Sam's example, just start throwing them into the questions tab and we'll try and cover them towards the end. Perfect, let's dive into Mads' example.
Manipulating faces is one of those very tricky aspects of compositing. It's something that I find extremely fascinating and I absolutely love to work with. And so that was one of the things that I really wanted to dive into when I started using the CopyCat node. It's easy to get some input A to represent some ground truth B, like having a completely random input and training that on a series of faces. But you want to be able to control the system and have some kind of relationship between the data you input and the ground truth. Not only to make the training easier and better, but also leave room for artist interaction. So one of the first things I did was to create a representation, mainly using paint strokes that will represent different key facial features, and then using the Nuke smart vectors to drive those. And so by providing a single still frame as a texture and then animating the strokes, I was able to drive the animation of the face based on that single still image. Each stroke had a unique color to represent an ID. I also tried just having small dots with a unique unpremultiplied alpha value, but that didn't necessarily work as well. And later, I tried replacing the strokes with a spline warp and an ST map to fill in the gaps between these features. But there were a few issues with this approach. First of all, you need to be consistent with the way that you place the markers. Secondly, you need to adhere to the topology and the sort of constraint relationship between the points of the face. Like if you move the jaw down, you most likely want to take the bottom part of the lips with it. And lastly, there is this spatial relationship with the cropping size and how I use a single still to define the texture of the face. When you do your training, the crop size sort of defines how far away you can be from the original origin. So if I had a crop size of 256 during my training, you can think that there is like a 256 pixel constraint radius around each point. And as soon as I move the point outside of this area, it will no longer be able to read the data of the face texture. So what I needed was some kind of template that would allow me to set the points easily and add sort of natural human facial constraints to the points. And rather than providing a texture, let the model CAD file carry the texture of the face. And so at this point I realized that it would probably be easier to just have a 3D model representing the face. And so for this I decided to use the Keen Tools Face Builder and Face Tracker. The first thing I wanted to do was to test the temporal stability of this setup. So I provided a few images of me as an input and the normals of the 3D match move face as the ground truth. And even with just a handful of training images, the output was fairly stable. This could be used for some creative masking or fake relighting or whatever. Now it's time to do it the other way around, giving the UVs of the 3D match move face as an input and my face as the ground truth. While normals are just a soft gradient, and I guess that's why it didn't require too many images, facial texture is much more defined, and so for this training I needed a few hundred images to get a good result. Once training was complete, I could generate a face from the UVs of the Face Tracker tool. And using the Pin tool, I can control the facial features easily. Now one of the cool things about this Keen tool setup is that the model transformation and the model deformation is handled separately. This means that I can control the dialogue of the face independently from the general actor performance. So now I can pick the perfect dialogue take with the perfect performance take. And I guess we've all been in the situation where the story beats of a film of a TV series have changed, or certain important details of the story needs to be emphasized, usually with off-screen dialogue or something crazy like that. Well, now we can take the dialogue from a dubbing performance that we record 6 months after the shoot and transfer that dialogue onto the old plate. Sort of a digital dubbing.
Thank you, Mads, for that great example. Is there anything you wanted to add before we dive into Hendrik's?
Yeah, one thing I forgot to mention was that the Keen Tools face model, it doesn't have teeth and it doesn't have a tongue and it doesn't have gaze. So if you want to do this properly, you most likely want to have like ads, like a card inside the mouth, and then anchor it to your like this, and then a card in the bottom and anchor down here. So you can have the teeth, because otherwise the mouth doesn't resolve as good. And then for the gaze, of course, try to do a tracking of the dark part of the eyes against something like here. So yeah, I guess
Perfect.
that's kind of what's missing
Thank you,
in order
Matt.
to get it to look awesome.
No problem. Thank you so much for adding that. Perfect. So last but not least, let's dive into Hendrik's example.
This shot from music video erected by Estonian artist Tommy Cash is a good candidate for copycat-based cleanup work, because one of the copycat's strengths is coping with amorphous moving and transforming surfaces like reflections. A few knights are marching on a field, and in the armor reflection we can see a movie bird arm and some people in the background, which we would like to get rid of. It is usually beneficial to constrain the work area, because then training can concentrate on aspects that are more relevant to our task. Stabilizing the plate and cropping is the easiest way to do it. I also shuffle the stabilized plate to a new layer, because then I can easily access it as input training data with all the intermediate transforms applied. For first session of training I used just one single frame. With a bit of paintwork I produced the so-called ground truth image. Ground truth defines what we want our input frame to turn to, and CopyCat model learns how to transform from input to ground truth. This transform can then be used on all frames of the shot or a number of different shots in sequence to apply the effect. To make trained model more resilient to object movement in screen space, one simple way is to generate additional synthetic ground truth frames. For this I use transform node and random expressions for rotation and scale. After training sequence is done, I bake out the input and ground truth frames. Always make sure that the input and ground truth sequences are properly aligned both spatially and temporally. For training, connect input and ground truth to CopyCat node, set parameters as needed and let it run. From the training graph we can see that loss is gradually getting lower and lower, which is what we want. With 10,000 epochs and 10 frame sequence, first training session took around an hour with RTX 2080 Ti GPU. As we can see, first results look pretty good. Reflection has a nice natural feel to it and actually looks like a reflection. There are some offending black areas in second half of shot which appear to the increasing differences between training data and input. Model doesn't know what to do with these new emerging patterns. To fix this, one fast option is to use the produced inference as basis for additional ground truth frames. Run plate through inference, add some paint touch-ups and append into training sequence as new frame. With retime node it is turned into infinitely looping clip that is then cut to training set length, pushed through synthetic frame generation and saved as new training data. For a new training session I usually create new folder to version the training data up. For initial weights, results from previous training can be used. This allows starting from where previous session ended, but with new training data. As can be seen from graph, loss is already pretty low and new session manages to lower it even more, while training to produce new ground truth frames in addition to previous ones. After training for an hour, previous offending black splotches are mostly gone. To see our semi-automatic paintwork in action, separate the area of interest and merge it over original plate. CopyCat training is more effective on denoised plates, so regraining and so on should follow as usual. For any remaining problem areas, simply repeat the ground truth frame process. Adding new frame holes and appending them together is kind of tedious though, and it occurred to me that Richard Fraser's optical frame repair gizmo would help here. It allows setting keyframes on frames of interest and compresses them to sequence. For frame repair it then expands them again using OFlow, but for CopyCat we want just a frame sequence, so simply disable the OFlow node inside the gizmo. Do your paintwork, mark the ground truth frames, press rebuild and pick up the dropped sequence with frame range and the pen clip nodes. For second example I'd like to show a more experimental test. I have ordered some images of apples and oranges to use as ground truth. For inputs I use the most basic shapes, soft circles. For red apple, red circle, for green, green one, and for yellowish apple, yellow circle, which is the additive version of red and green. Orange is white circle formed by adding blue. Is it possible to train a model to turn these same sized circles into different fruits based on color? After a bit of training, an interesting fruit morpher is created. Feeding the inference node with red and green circles that gradually overlap produces a visual morph from red and green apples to yellow apple. If I then add blue to it, it morphs into an orange. But what if I create a pattern of random circles? Well, I get a fruit generator. By clipping and blurring some noise patterns, I create the dot pattern. that when fed to trained model hallucinates a canvas of fruits, appearing and morphing into each other randomly. But what about the shape itself? Is it possible to encode, for example, the size of circle into different objects? Well, yes, it is. Let's try with some numbers. Text node creates a number for each frame using an expression. As input, they use a soft circle that grows over time. After some training, model is able to turn different sizes of exact same shape into different numbers, softly morphing between them. After number 10, it turns into a mush because training data only ran up to 10. And I believe limitations of learnable pattern size inside the model itself might also come to play here. Using the same dot pattern generator, it's possible to hallucinate the canvas of random numbers, similar to fruits, simply by changing the size of dots. What the practical use case for such generators could be is yet to be discovered. CopyCat is a very flexible platform for all kinds of funky effects, and we have only scratched the surface of it. Thank you for watching.
Wow, some really cool examples. Thank you so much. Hendrik, is there anything you wanted to add before we start jumping into the next part?
Yeah, maybe just as a comment, I'm really interested in the mechanics of how stuff works usually, because I'm more technically inclined than artistic. And the second part of taking the absolute most basic shapes and trying to encode them into something else is something I try to do to get a better handle on how CopyCat actually works as a system and where the limitations are. So I think starting from the ground up and building on top of different ideas, there are so many things we can do with it that are not simply like image-to-image transfer where we have like a full final frame and then we do some paint and get some other frame, but we can do crazy stuff with it.
Absolutely, yeah. No, I agree, 100%. Perfect. So let's dive into just a couple of the panel questions that we've put together then. Shall I take the first one?
Sure, go for it.
Perfect. So the first kind of question, what were you most excited about when you heard about CopyCat in Nuke 13? So I'm going to start with Mads.
Oh, that's
put you on the spot there.
Actually, the first video I sort of wanted to make was actually just a conversation between me and Xavier, who I featured here in the video. We sort of, we had sort of this process of like, I figured out that the alpha was out, and then he downloaded it, and then we was like pushing each other to like figure out crazy ideas of what to do with the CopyCat node. And there's just so many things. There's like a giant bucket list of things we could try, and so we were just constantly pushing each other to find new crazy ideas of what to use the CopyCat node for. So it was just so much joy. It's rare that you get those kind of sort of those moments with new tools. It's really interesting because it's like it's unlike any other tool in the Nuke arsenal. It's not like a 3D tracker where you could do 3D tracking or a paint tool where you can do paint. It's like Dan Ring said. He said that it was like it was fit by the artist's imagination, and I think that pretty much highlights it.
Awesome, thank you, Mads. What about you, Sam?
Yeah, it's kind of, for me, it was like most tools are directed. Like you color correct something and the color comes out corrected. This is, instead of being Grand Theft Auto, is like an open sandbox thing. You can do whatever you like with it, and you can put in whatever you feel like into CopyCat. And chances are, if you understand the X to Y sort of process, you can let your imagination run wild. And I worked as a rendering TD for a while, and I sort of thought, how cool would it be to be able to just put lighting onto 30 shots by loading up one file? And so I applied it to that. But like it's just as much imagination as you got. You can use this tool to solve problems, and it's just wonderful that it's out there and so easy to use.
Definitely. Certainly. Thank you for that, Sam. Hendrik, what about you?
Well, my first thought was this is great stuff because I don't have to mess with machine learning server anymore. Because when Foundry released the ML server, I jumped onto it and tried to make it work, and kind of made it work also. But it was so tedious to prepare the training data and get it run in the Docker and so on. And when CopyCat came out, this is great because now I can basically just use it, not have to mess with getting it to run. because I've been interested in machine learning too for quite some time now, but it's kind of difficult to get into it because it takes so much messing with scripting and all the frameworks and so on. And I think CopyCat is great because it's very easy to use, and basically all you need is the imagination, because technical barrier is taken away. So I think it's great stuff.
Speaking of the imagination, I mean, I was totally ready to be surprised by what you guys were doing with it, but the fruit generator has blown my mind. Like, I know you said we don't know what the use is for it, but we have to find a use for it, because that's awesome. It's all awesome. What are the main benefits you're finding so far? Any Mads? Any particular shots it's solving for you?
No, I think we're still like it's hard to like sort of when you do the budgeting, it's like figuring out, okay, sort of figure out is it worth it to budget for a certain shot for CopyCat, because you might not know it yet, and you might not know how long it's going to train in order to get a sufficient result, or if it's getting a sufficient result at all. And I think sort of we need to have like the supervisors understand sort of how much you can do with the tool and what kind of limitations and what kind of constraints there are. And I guess once they start understanding that and sort of understand how much work and how much time is going into it, or how little time, sometimes you get result quite quickly. So it's just like, having people understand sort of the training process and what the results are. And I think once we start to get that, I think it's going to be used a lot more, because we have had so many tricky shots in the past, like actually with faces and reflections in faces and things of that nature, where it's a bit too complex usually. I mean, unless you do a full digital double. And in those cases, this would be better than, than just going down that route, or had say to the client that, sorry, we can't do this because it's just too complex. So I think it opens up a lot of cases, and we have had those issues in the past. But it's all about getting to know the tools and having the people who actually do the budgeting, figuring out how if this is approach to use, and also for the artist, because if they run into an issue where they think that, okay, this could I cannot do that myself, but I could probably teach just a few frames and then get some results in there. So it's just about getting it into the hands of the people and the artist, and then they'll get to know it.
Cool. Sam.
Yeah, I think it's kind of putting the power back into the data, rather than having to be a propeller head and having to fiddle with Python and fiddle with the runtime environment and all those sort of things. It's just making it about, like, if you can have a thought and if you can understand that you're transferring an image from A to B or X to Y or whatever you want to call it, and you can collect up some data. You might even have data out there from previous shows that is usable by CopyCat, and you can train that. And so I guess, one of the concepts that I haven't really been through is like the specification versus generalization, where you can sort of make something work on one specific example, or you can make it work on all of the examples. And I think that's where CopyCat really shines, is for small data sets where you just want to make something work on a handful of shots or one particular asset. In the past, that would be too prohibitive to sort of spin up a data set and get a machine learning model going. Now you can sort of do a 15-minute experiment where you cobble together an X and a Y, throw it at CopyCat and see if it starts converging, and just run your experiment sort of from 30 minutes before knockoff until your machine's finished rendering in the morning, and just come and harvest the fruit of the overnight's sort of GPU baking. And I think that's where people are really going to get into this, if they've got a spare GPU laying around, that they can just iterate on things and get to know the medium and get to know what the data can do for them, then they can really get the most out of this tool. And I think, that's the glory of machine learning, is being able to just use it like putty.
Great. And Hendrik?
For me personally, I think the lowest hanging fruit, which I'm going to use CopyCat for from now on, is all kinds of paint work, because I do quite a lot of paint, and it seems to be pretty straightforward with CopyCat, and also pretty predictable of what the outcome will be. I think, and what Sam told, I think this is one of the major points of CopyCat, that it doesn't have to be general, the solution, because I don't care if my model can remove someone's birthmark from every random shot from the world. I only care about my current shots or a sequence. So if I train it to do this on these shots, then whether it works somewhere else, I don't care, actually. So I think this is the main big driving idea behind CopyCat, and like a specification, not generalization.
Yeah, the funny thing is that can actually use the same model for generalization if you do want to, just as a note for everyone. But going to take a lot more data. Cool. So you kind of touched on some of the challenges as well in using it, because it is a new way of working. Any other challenges beyond, so Mads, you mentioned that, knowing if it's appropriate for the shot. And I think that's going to be an intuition that people are going to build up over time. Anything else that's leapt out to you as challenges?
Yeah, some of the, I mean, you once you start getting used to also like one of the questions in here, like just having like the RGBA channels, you kind of, you think, okay, maybe I want like a face and I want to like, I don't know, relight the face or relight a 3D model or something like that. And you think, okay, what if I gave it the normals and I gave it UVs and I get a light direction and so on? You easily start to add too many channels that are just not in there. So I think sort of figuring out how you can compress that data. And I still sort of haven't found the perfect solution for it yet. It's like if you have like a small image that you want to apply to the whole thing, same thing like relighting, and you want to have like HDRI, and you just have a lot of small ones, do you need to tile it and then let it know the position, like ST map or something like that? So it's like there are so many things where you want to add more data to it, and sometimes it's just like figuring out, okay, maybe it's just efficient just to get it like just the luminance channel, and then it can figure out the color channels by itself. So maybe you can constrain yourself by just not using unnecessary channels, I guess. So,
I mean, probably the best solution to that is if we just add more channels into it.
Yeah, that would be nice.
So going ahead and answering that question, yes, it is limited to 4 channels at the moment, but that's a temporary engineering constraint. So future releases, we can extend that. Hendrik, how about you? Challenges? Seen any new ones?
For me, I think the greatest challenge is trying to break out from the black box type of effect, which CopyCat probably is when you first like open it up. You put something in, it does something, something comes out, but you can't really reason about black box. Yeah, and what I'm trying to do is to get a technical understanding of how it works, because then I can deduce from the type of model and all the other stuff. If I put something in, could something come out, or will it turn into like crap? Because just trying everything doesn't really work, because I want to know if I put something in, is there a possibility that it will work? Because training something for like 100 hours and then seeing that it won't improve, I don't have so much time to do it. Yeah. Trying to grasp the underlying principles, I think that's the main difficult part of CopyCat. Yeah.
Hendrik, in machine learning, sort of in research, we use things called attention maps, and you can actually see which layers are getting excited and where the flow is. And sometimes these attention maps have relationships to spatial features. And so if you get some of these in-between layers and they're highlighting your fruit or your mandarin or whatever, and you can actually get to the point where you get sort of explainable AI. But that's a big area of research at the moment, is actually being able to understand what's going on inside the networks and be able to see that. And it's hard, like this is one of the things. It's magic, and sometimes the magic can't be explained and sometimes it can. But yeah, it's a good thing to work towards.
Yeah. I think one very simple example is Matt's also talked about it. Is how does the crop size affect your effect or what you're trying to achieve? Because what I also learned is that crop size kind of dictates the size of the features that the model can learn or can transfer. Because any feature that is bigger than the crop size, or maybe half the crop, I'm not too sure, it can't be expressed anymore, because model learns by cropping these small tiles, and if your feature doesn't fit into one of these crops, then essentially it's not a single feature anymore. And that's one of the things that I tried to explore with these very simple spheres and shapes and stuff like that. Also, where's the limitation of this?
Yeah, Hendrik, I mean, I found it really interesting what you did, where you sort of tilted your input one way and you tilted it the other way, and then, you know, you could do color offsets in normal machine learning. That's just called data augmentation, and it's actually a thing. And one of the data augmentation things you can do is you can go from a large crop size down to something smaller, and some machine learning models are scale invariant, so that they've got multi-resolution inside of them, so you can actually train on big images and infer on small images. But yeah,
that CopyCat is one of those scale invariant models. So yeah, data augmentation is a massive thing. So we're going to put out some more tutorials with it. But again, it's probably a feature we want to add somewhere in the node later, and so you don't have to do it yourselves. So Sam, any additional challenges you've noticed?
Look, it's going to sound like a naysayer, but just the resource intensity. Like, I've got a machine here with 2 GPUs in it. You know, I'm very lucky, and, you know, I managed to get some 390s while they were available. And I found that it was training just on one of the GPUs rather than on both of them. And so I suppose if people are time poor and they wanted to train a model on 8 GPUs in the cloud, they should be able to hire a box with 8 GPUs, you know, for $1 US an hour, and have it come out in a fraction of the time for the number of GPUs. So I was fine. I just let it go on a Saturday night, went out and had some drinks, and came back in the morning, and it was all done. But I know that a lot of production schedules time is money, and so that those long periods of time for training can be sometimes a little bit limiting.
Yeah, it is a whole new way of working, really, isn't it? And so with that in mind, who do you think within a studio is probably the person who's going to be using CopyCat the most? Is it your average artist? Is it TDs? Or is it potentially even someone new, a new role? Sam?
Yeah, I can answer this. Look, I would say that the people who know the data the best would be the best people to use the tool, or at least feed the person who might be a TD or whatever. So if you had somebody in turnover or running dailies or whatever, and they know who's creating a whole heap of data, which is very much same as for that generalization purpose, or is seeing, oh, everybody's getting killed by this paint shot, why don't we give CopyCat a go on this and funnel all the data together into a neat sort of format, and then just throw it at the render wall and let it come out in the morning, and sort of have these zero cost bets where you've got existing data and then it's coming out with a trained model, and then you just try it and see if it solves some of those problems for free. Because, you know, this is the beauty of automation, where it can just sit there and solve things that could be really expensive. And, you know, if it's just you know, a few GPUs on the farm, then it's a pretty cheap experiment compared to paying somebody's wage to sit there doing roto or paint or whatever. And then, you know, further to that, you get to a point where you've got artists who, you know, potentially are on salary and are somewhat idle. They can start running experiments. So as a sort of reward for getting through your tasks a little bit quicker, you can have a little bit of playtime on CopyCat and, you know, maybe do something mad like the fruits or whatever, and sort of have that as a reward when you're on downtime or whatever, to have a little bit of experimentation and see if you can come up with something serendipitous. So in answer to your question, I reckon it would be editorial and as sort of a downtime, mad experiment time sort of thing where you've got somebody creative who can sort of see what the potential is and just allow to take some R&D time and try something out.
Interesting. So it's like a little treat in Nuke for people. How about you, Hendrik?
Just before we just quickly continue, after this one, just conscious of time, we should probably dive into some of the Q&A part as well from the audience. Perfect. So let's just run through the rest of the, let's just cover this question as well, just quickly.
I think Sam is right. In bigger studios, it has to be someone who has access to all the data, because if you're not applying it to just a single shot, you need to have the coverage of all of the whole input space, all the shots that are possibly going into it. And one of the aspects that I've thought of, but I don't really know how it will work out, is, for example, if you train the model on a set of shots, and then the next show comes in, and you want to kind of add those into the previous training, you need to have access to all the previous shots also. Otherwise, the model will start to kind of steer into the other data set and slowly starts to forget the previous one. I think, at least my intuition does this. So if you want to build the model more like general, you always have to access to all the previous data sets also. So this has to be like a growing pool of data set. And I think this needs a dedicated person or mechanism to do it properly.
So you see people building up models, big models over time within the houses.
Yeah, if they want to generalize it, it has to happen sometime like this, yeah. Because if you just take a new data set and drop the old one, the model will start like steering this way, that way, third way, and all the old knowledge is kind of dropped.
Cool. Mads?
No, I mean, I perfectly agree with that. I think it's a good question regarding sort of how you. I mean, if you need like to maintain like the big data sets and get something to generalize, I think there are a bunch of things where you can like generalize where it doesn't necessarily require you to have things like the SAM example where you're like adding texture to UV pass or cryptomat pass, I guess, or something like that, where you can start adding material or adding shadows or like Fox ambient occlusion or things like that, where you can get some very good generalized models that can be sort of applied across multiple shows, multiple different shots, where it's not necessarily depending on the input that you give it. So that's one of the things that I'm looking forward to see if anyone can come up with something that could be shared on like Nukepedia and stuff.
Cool. Thank you so much for covering all these questions. Just a little bit conscious of time. We've got quite a few burning questions from the audience. So let's dive into those. So I'll take the first one. So I saw a very good question from Sam Alessandri. How often in commercial production are you guys using CopyCat per job roughly? Also, what's a good card to run this often? Mid-range, sorry. Who wants to take this question? Any volunteers?
Well, look, I can answer that. About the card, I think get as much video memory as you can afford. And I think there's a really good price point with the RTX 3060 with about 12 gig of RAM. You should be able to get a reasonable batch size without spending a fortune. But I think you can probably start experiments with a small batch size. As for how much I'm using it in commercial production, I'm a software developer at the moment rather than working on features anymore. So I can't really say, but maybe this is a good time to hand over to Mads and Hendrik.
Yeah, I think for our sake, we haven't yet moved up to Nuke 13. It's just some pipeline things, the Python 3 constraint that's usually that's causing people to a little bit on that. So we haven't started, but there have been like a few cases where we was like, okay, this could be interesting to try with CopyCat node, but yeah, we haven't moved up to that yet. So.
Yeah, I haven't used it in any production shots yet. Also, the shot that I showed in my video from the music video, I did that about a month ago, the project, and at that moment I wasn't too sure if CopyCat could make it, but that shot like kind of ticked in my head because it was a perfect type of CopyCat shot to try to work on. So now for this demo, I dug it up and got permission from Malfilm to show it here. But I have been bidding with CopyCat in my mind lately for new projects upcoming for different paint jobs and stuff like that.
Awesome. Thank you. I just saw one more really cool question, and then I'll hand over to you, Ben. Sorry, let me just bring this one. What was the coolest application for CopyCat you've done so far? Who wants to take the first stab? Anyone?
Yeah, I mean, I guess, every project that we've been working on has been like super cool. That race, like figuring out what kind of things you could do with it. One of the really cool things was like rendering out every second frame and just teaching it on a few frames, like for a sequence of like fluid simulations, something Xavier did, where you a few of the renders, you added like the middle frame, and all the other frames you just rendered every second frame, and then you could teach it to like do the smooth interpolation between the frames. Actually ended up with quite a cool like Kronos on steroids. And the other thing was like up-resing fluid simulations. So we did like a low resolution voxel based, the low resolution voxel fluid simulation, and then upscaling that using, just from a 2D perspective, upscaling that to a much higher and getting a lot more details on fire and stuff like that. It was really, really cool to see, I think.
I didn't get to finish it off, but I just took a public Pix2Pix data set, which was of facades, building facades, and it just had block colors for where the windows are, a block color for where the mantle is, a block color for a veranda, or features of the building, or just had a block color. And it was able to learn how to do that. And to finish it off, you could sit there and take a bunch of buildings and then put up a bunch of cards and be able to do a whole environment setup where you're generating, procedural buildings for a matte painting would be really, really good use of CopyCat. But I haven't seen that taken to end completion. I'm sure somebody out there could use that idea.
I have to say fruit generator. I tried lots of different stuff. Most of it kind of works or doesn't work. For example, I've tried style transfers and all kinds of generators and this NVIDIA had a project called Gaugan, which generated landscape images from like MS Paint type of drawings with solid colors. I tried to make that work also. That doesn't work too well. But yeah, I like the fruits.
Awesome, thank you. And just going over some of the other questions. See, Ben, did you see anything that?
Yeah, I can't figure out how to make it live though.
And you should have a button called. Oh, hold on. Sorry, now it should work for you. Sorry.
So, people are asking, is there a place to publish their models and share with the community? There isn't currently, but Matt's kind of touched on it with, I'm guessing, Nukepedia would be the place for it. What do you guys think?
Yeah, that would be a good place.
Yeah, we do tend to, sorry. We do tend to sometimes add some of the trained, some script and some tutorials on our Learn page as well. So keep an eye out on our page there where we add some of those things too. Sorry, Sam, you were saying.
This sort of brings to the point of who owns a trained model. Like that's a really interesting thing. Like obviously somebody's labeled that data or come up with the ground truth, and most people are allowed to share and share alike. But if you're working in a pretty locked down studio, I mean, people wouldn't be allowed to do that. And yeah, it's a really interesting thing to do. That it'd be really nice to be able to share your things. And if it's like a little experiment like Hendrik did where he took some photos of some fruit, but if it was Spider-Man or something else like that, then that kind of belongs to Marvel, and it gets tricky.
Yeah, there are a lot of interesting new legal questions that come up. I think, is it? Yeah. Oh, I can't even get the question up. Mike Seymour's question about, using copyright material. Yeah, it's a whole new world. And I think the lawyers are going to have a lot of fun figuring questions out.
Somebody's going to have a precedent case, and, then the lawyers will work it out. But, yeah, it's tricky.
Perfect. Let's see if there's any. There is a question from Priyank Parekh, and he's asking, wouldn't it be helpful to get better results if we are able to merge two custom data sets on CopyCat node? Anyone want to take this question?
So I can take that one, potentially.
Yeah.
I think you kind of, there's two worlds with CopyCat. There's kind of making it specific to your data, and then there's generalization. And two different data sets, well, assuming when we say data sets, we're talking about shots in this case, probably is not enough to generalize, but then is going to dilute it for a single shot. So I think probably you're going to want to either like make it specific to your shot or something very similar, or go big and try and get your thousands of images.
Yeah, that's also something that we reached sort of with trying to do faces. Usually like the lighting part of the face. If you do it on like two different lighting scenarios, then it kind of does some wonky things sometimes where, it doesn't have the data for a certain mouth position or something like that. And then it'll suddenly add that sort of super bright spot over at this cheek, even though it's in shadow. So yeah, at that point, you probably need way more data in order to get sort of a more generalized model.
Yeah, I guess there's the concept of fine-tuning a model, right? So if you had a generalized model which was all the faces on all of the internet, right? And then you took that as the general model, and then you wanted to put in your favorite actor in there and fine-tune it on their face, you could get a very generalized model which has got all the faces, and then you could make it specific to Robert De Niro, for example, and then you could have the Robert De Niro deepfake. But what you could do is you could have all of the training of all of the faces of the internet to fine-tune, or even, there's a concept of one hot shot where you find the closest match to a specific model, and you can just sit there and take something that's generalized and make it specific for one shot. And that means that you can sort of, I don't know, what's the term, memoize the computation from something that's been done in a big form and then sort of specify it. So it's not really joining data sets, it's actually kind of splitting them out or building on top of a foundation from a larger data set. And I think that can work pretty well.
Yeah, there is a thing in CopyCat where you can initialize from a set of weights. So yeah, you can start from your generalized one and, like Sam says, fine tune if it's a similar task.
I saw a really good question that just disappeared. Oh no, I've lost it. Apologies, my bad. People can, when you upvote it, it tends to move around. So I'm just trying to find it again. Oh, there you go. Sorry. There's a question from Attila Gasparets asking, would you recommend artists to learn coding on a level to be able to use the ML server in Nuke still, or just wait till more customized user-friendly tools gets released?
We released the ML server a while back as a way for people to kind of get up and running and try out some stuff with machine learning, but it's not no longer a sort of officially supported tool, and we're not doing any new development on that. So I definitely wouldn't recommend people to start learning to code in order to use that. As for the customized user-friendly tools, well, that's what CopyCat is, really. So CopyCat is the user-friendly version of ML server, so I advise you to go onto that rather than learning to code.
Yeah, look, I would say that there's benefit in both, like actually getting to know the medium. You know, like if you're a painter, knowing how the pigments of your paint work and knowing a bit of color theory is really good. But if you just want to take a photograph, you pull out your iPhone and hit go and you get a perfect picture, right? So I think, you know, having an appreciation for machine learning and messing around in Google Colab or Python notebooks or whatever you want to do, that's all beneficial, but that's probably leading you down a path to being a machine learning expert rather than being an on-production artist. And both things are great. You know, those both lovely people and good fun to hang out with, but it's not necessarily the same person in the same body. You'll find that with some people, but so I would say if you want to get down and dirty with code, do it. If you want to have the butler service with CopyCat, go do it. I mean, I don't think there's a loser in any of those situations.
Yeah, I think Sam is right. If you want to understand the mechanics of CopyCat, poking around in the ML server code and trying to understand how it works is a really good thing. But if you just want to use machine learning as an artist, it's not necessary. Especially now when CopyCat is out and you don't have to run ML server anymore.
Yeah, the ML server can be tricky to get going if you don't have good sysadmin type skills, so be aware.
All right, so I'm conscious of time. We're on the hour. Is there anything that you guys saw that you wanted to cover from the Q&A? Otherwise, I think we'll slowly have to wrap up. I think we've covered most of all the juicy questions.
Look, somebody asked me about scene files. I'm quite happy to hand over my fence if anybody's curious about having that as a data set, or you know, maybe hanging around with Joyce after the talk and link to some of the data sets that I think would work well. And maybe that can be posted up with the talk or something like that. And I'm sure Ben's got plenty of example scenes or whatever that people can just dive into and keep their room warm with the GPU running overnight.
Yeah, so there are some a load of tutorials we've put up on our YouTube channel. They're pretty in depth. I don't think they've got files associated with them at the moment, but we should hopefully be able to release some files at some point in the not too distant future.
For sure. Perfect. Well, we'll have to wrap up from here. Thank you, dear panelists, for joining us today and sharing all of your experiments and experiences in CopyCat. Thank you so much, Ben, for joining me today to host today's webinar. And thank you, dear audience, for listening in. I hope you found this webinar insightful. As I said, the webinar is recorded and you will see the on-demand load up to this page as soon as this webinar ends. If you have any questions, please send us an email on virtual.events@foundry.com. Stay safe wherever you are in the world. Thank you again for joining and see you very soon.